Newton's third law of motion. For forces, there must be two objects involved. Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. So the force exerted on the table by the cat is opposite and equal to the force exerted on the cat by the table. Another way to state Newton's third law is that for every action, there's an equal and opposite reaction. The two objects involved are called an action-reaction pair. The forces, or actions, are applied to each object. One force is exerted on the first object, and the other is exerted on the second object. The forces are applied to two different objects. Forces only exist in pairs. A force does not exist by itself. A key to the correct application of the third law is that the forces are exerted on different objects. Make sure you don't use them as if they were acting on the same object. Then they would add to zero. So here, there's a force on the hands, and there's another force, opposite and equal, on the floor. Rocket propulsion can also be explained using Newton's third law. Hot gases from combustion spew out of the tail of the rocket at high speeds. The reaction force is what propels the rocket. Note that the rocket does not need anything like the Earth to push against. The rocket pushes on the gases, and the gases push on the rocket. Subscripts help keep your ideas and equations clear. So let's say when you're walking down the street, your foot is exerting a force on the ground, and the ground is exerting a force on your foot. So you can call this one force foot, that one force ground, whatever you would like to keep your thoughts clear.